Good morning, everybody. So, for today's class, we will be starting on how to use Geomagic Design X Go to extract lofted surfaces and mesh fitted surfaces. So, we can begin by going on to the Import tab. So, where you see Import, you can click on Import and say Import Scans. And here in day 2, we will be able to find a file called fanblade.stl. So please select fanblade.stl and import it as a mesh. So have points only unchecked and import it in the correct units. So as we can see, the file is getting loaded up in the screen. And here we have imported this fan blade. So we can hide our front, top, and left planes first. And we can see that this is a damaged fan blade. It only has 1, 2, 3, 4, 5 blades. And if you zoom in, you can see that some of the blades are in a good condition. Like this blade is in a good condition, but some of the other blades, for instance, this blade, it has a lot of corrosion and damage. So in this particular exercise, what we are going to perform is we are going to look at a rotational sketching type of an example for the outer housing of the fan blade, like for this particular area, following which we'll extract the blade surface for one of the blades. And since we are using Design X Go, we don't have a lot of surfacing features in Geomagic Design X Go. However, I will be showing uh, a continuation of this particular process in a CAD program. So to begin with, we see that there is this body which is having a rotational shape. So we can start by selecting some of the polygons there. So where you see my cursor, I'm having the rectangular selection mode on, and I'm having the visible only selection mode. So I'm selecting a broad portion like this, and then I rotate the model and I keep it in a comfortable position slash orientation, and I add more data. So I can add more data by holding shift on my keyboard and selecting the areas that are needed. So I add more areas to my selection like this. Now I'll do one more side. You don't need to take the whole item. You can also select it like this. But depending on the area that you have chosen, we are going to extract the axis vector. So here we have this particular body. Now you can go ahead to the model tab. So you can find the model tab on the top. And from there, we have the vector option. So you can select vector. And here in vector, since we selected the polygons before we clicked on the vector, it has already added those entities in the entities option here. So it says here polyfaces of fan blade. Now in the method, we can go and choose an option called revolving axis. Now this point revolving axis works for any generic revolute structure. So you can choose that and you can say apply. And the software is going to take some time and find out the axis of the selection that you had made, and you can say OK. So here we have vector 1, which you can rename as the revolve axis, or whichever terminology sounds comfortable to you. Now once we have done this particular axis, we can choose a plane. So I can go here and say make a plane in the model tab, and in the model tab we can choose the method find plane using the pick point and coplanar axis method. So you can click on pick point and coplanar axis, and you can see that the software asks for some entities. So I'm going to choose this revolve axis, and I'm going to choose a point. So I'm going to choose a random point like that. And as you can see, it has made a coplanar plane. That is, the vector and the point lie on the same plane. Or in other words, you can take 2 points on this vector and connect it with this particular point to get this particular plane. Now you can say OK. And here we have our initial sketch plane, which is plane 1. Now till now we saw the process of planar mesh sketching, but if you go into the sketch tab and if you select mesh sketch, there is also another option called rotational mesh sketching. So you can click on the mesh sketch tool, and right away you'll find that there are two radio buttons. One is planar method, the other one is called a rotational method, and it also requests for a base plane. So you can change the drop down to rotational method by clicking here, and when you click on rotational method, it opens up two boxes. There is a central axis and there's the base plane, which was already present. So regarding the base plane, it is the plane in which you want to make your sketch, you want to draw your sketch. So you can choose the base plane as the plane which you constructed, plane 1. And for the central axis, it's going to be about this vector. So you can click on the vector and choose that vector. Now, like you saw in the case for planar sketching, here as well you see a preview, and if you're fine with doing only one side for the preview, you can limit by clicking and holding this box and narrowing it to where you need it to be, like that. And if for some reason if you feel like this area does not have good quality scan data, you can always zoom out and you'll see a thin green ring. So you can move this ring to where you feel there is a very nice scan data available. Say for example, like in this region, you see the scan data is good. And if that preview looks good, you can say OK. So the software would automatically take that particular cross section and it would rotationally project onto your base plane. So here we have a preview which looks like this. Then we can start by making our center line on the vector. So I am keeping both points on the vector and drawing my center line. This is the axis about which the body is going to be revolved. And we can see that this structure is pretty much like a 3-point arc. So you can click here, you can hover over with the 3-point arc tool and double click here. And there's another tool called tangent arc. So you can click on tangent arc and you can hold and draw your arc. So you can click on this particular vertex. So you can click on vertex 1 and you can place it on top of this trace. So when you do that, you'll see that a tangency icon pops up, and this icon indicates that the second curve is tangential to the first curve. So we can do that process again. So here we do a 3-point arc and we can do a tangent arc following it. So how do we do that? We click on this particular point and we drop it to wherever we find comfortable. You can also drop it here and make another tangent arc and proceed on and on. So you can like comfortably keep dropping your arcs like that so that it gives you a good fit. Now we see that there are two of these line segments here. So I go back to my line tool, I hover my mouse, it turns yellow, and I double click to get a best fit trace. And I repeat the same process here again. Now we have completed this particular section, and over here we have a line as well. So you can double click and best fit a line followed by a trim. So you can do a corner trim like that. And you can also see for disjoint ends by going into the accuracy analyzer tab on the right side, and you can check for disjoint ends. So here it's going to show you all disjoint ends. So as you can see, there are some disjoint ends here that need connection. And anytime if you feel some curves are displaced, you can also click and move them, and you can also drag these points and place them accordingly so that the deviation is minimized. Now, following this, you can use your fillet tool. So you can click on this arc, and then you can click and hold on this line and move your cursor and place it appropriately so that they're on top of the trace. So I can click on segment 1, then I can click and hold my mouse on segment 2 and move my mouse and place it so that we are on top of that pink trace and say OK. Now you can also connect these two segments with a line. So I can make a line going like that, and I can trim them out together. This is pretty much the same sketching workflow that we followed in all our previous exercises. So here we have made this particular sketch. Now once the sketch is complete, we can see that there are no disconnected ends and the curves are fitting very well on the trace. You can also show the deviation in this particular arrow diagram, and if you hover over your mouse, it will tell you what the deviation is at each of those points. If you want to see it bigger in the accuracy analyzer, you can drag those mouse that scale, and you can see an exaggerated deviation between the trace and the scan that you have. And once this is performed, you can come out of this particular tool, and here we have our first sketch. So now you can go into your model tab. We're going to do a simple revolution. So click on model, and the second option is a revolved solid. So click on revolve, and it asks you for a base sketch. So you can choose sketch 1, and automatically it shows you a preview of the revolute object, and you can say OK. So now here we have this particular body installed. So again, we are here in the revolute object. We choose insert for 360 degrees, and axis is curve 1, which is the center line that we drew. So here right away we have this particular item extracted, and you can check for the accuracies with the deviation plotter tool. So now that we have made this particular outer structure, we can hide our solid, and we can see that this structure has all these blades that need to be extracted. So these are very thin blades, so we can just extract one particular face of this particular blade. And if you look here, this blade is a pretty good blade. The first blade, like this blade, this part of the blade looks good. On the second blade, it has a lot of corrosion in these areas, so we are not going to use that. The third blade has some damage in this section. The fourth blade is also having some problematic areas where the scanner was not able to reach. And we can also use this particular blade. This fifth blade can also be used. So we can choose either or of these particular blades. And there are multiple ways in which you can isolate this particular blade. So the first option is to use a display technique. So here you can go to display, and where you see my cursor, there's an option called view clip. So this is basically to set a clipping plane. So you can check on view clip and hit on set nearby. And when you do that, it has a few different options. So you can say use it below plane. Below plane is like if I drag this plane holding this blue arrow, anything below that plane would be shown, and above that plane would be hidden. You can also rotate this to make it comfortable to your view. This is the between plane, below plane method. And you also have between two planes method, where you can like comfortably rotate and revolve these planes, so you can kind of turn this plane with the axis like that, and you can minimize the gap between them by dragging these blue arrows. so that you just see the items or the areas that you need to or that you want to see. So here you can rotate it again and adjust them so that we only see the blade area as opposed to the whole blade. And lastly, we have an option called inside box. So you can use this option and you can like move these box to wherever you feel comfortable. So here I'm moving this box this way. I'm reducing the distance here as well. And here I see these two blades. Now you can also rotate it about an edge. So you can rotate about an edge like that. And you can bring it in further. And you can bring this side in further. So here we just see this particular blade of interest. You can move this to the side a bit so that we see the entirety of the blade. And you can use any of these view clip methods and say OK. So now we have reduced the display to just view the blade. And in any case, if you want to see the whole blade, the whole part, you can uncheck this view clip and you'll see the whole part. And if you click on checkbox on view clip, you'll just see the view clip here. So here, as you can see, we have like selected just this particular portion. This is one approach. Another approach is to uncheck this view clip. You can come over here to meshes and expand meshes where you see my cursor. You can click on fan blade here and copy by clicking Ctrl C on your keyboard and then paste by clicking Ctrl V on your keyboard. Now if you look at the screen, you have a fan blade and you also have another entity called copied mesh. So you have two of them together. So you can hide your fan blade, which is your original mesh, and you can edit this particular mesh to just keep the items that you need. So here I just need this blade or this blade. So I'm gonna go to my polygon selector and I'm gonna keep my visibility into select through. And once I'm there, I'm gonna just select this thin section like that. So we select that blade area and then you can right click and say inverse polyfaces. This would select all the areas other than that blade area and you can say delete like that. And you can keep removing more items if necessary. So here I can hold shift and select these two areas and press delete on my keyboard. And you can also select this outer face and hit delete again. So here we only have this section of the blade, and if we need only this face, you can also remove this rear face. So I'm gonna use my smart selector tool. You can find that smart selector tool here. I'm gonna click and select that continuous region, and once it's selected, you can go ahead and click delete on your keyboard. So now we only have this particular face of the blade that we need to select. So now that we only have this particular section of the blade, the next process that we are going to perform is to turn this blade into a surface. So there are a few different ways to do that. The most commonly used approach for blades is to develop a lofted surface. So you can go here on plane. In the model tab, you see the planes tool. So we have the ability to draw a plane just like that. So you can orient this particular CAD file, this CAN file, in a way that it feels like you're looking into the blade. And you can go here to draw line. In methods, there's a draw line command. You can select that and it gives you this sort of a pencil. So you can click and hold your mouse and move it. So if you make a line like that and drop it, it's going to create a plane that goes through the normal to that view direction. If you make a plane like this is gonna give you a plane that would cut across that view direction like that. So you can choose draw line and you can cut out a plane, and that is gonna give you your plane 2. So our target is to cut a few planes like this across this particular surface and use those planes to extract some cross sections of the blade. So in order to make parallel planes, you can always go to plane, and in method there is a method called offset. So choose the offset method for making your planes, and it's gonna ask you for some entities. So you can choose this plane, and you get a blue arrow with which you can drag and drop. So I made one plane here, so I'm gonna make my second plane about 50 mm away, and then you have a number option here, so you can say 2, 3, 4, 5, 6, and so on. So you can make 6 or 5 different planes like this. You can also play with the numbers, so you can say make 60 planes, make planes that are 60 mm apart, and do only 5 planes. So it's gonna give you an offsetted parallel set of planes, as you can see in the image, and you can say okay here. So now we have plane 2 to plane 7, which are our 6 parallel planes. Now we can go ahead and make a sketch for each one of them. So I can right click on this particular plane 2 and do a mesh sketching here. And it's gonna show me a particular preview. This preview looks nice and crisp, so I can say OK here. Now you can hide your mesh and begin your mesh sketching process. So here, as you can see, there is like a arc type of a shape. So I'm gonna select 3-point arc and build up that arc. And you can also resize. You can see that there's some deviations here. So there's an increased amount of deviations here. You can also increase the vector multiplier if needed. And you can kind of plug it back in. You can pull it back if needed, and you can add another tangent arc to this particular line and place it on top of the trace like that. So you have extracted this particular cross section of this profile, and then you can go to the next cross section, put your cursor on the line selector mode, make a right click on plane 3 and do a mesh sketch. So here again, we have this particular sketch, so you can make best fit your curves this way, and you can move it back a bit and continue on with your tangent arc. So here I'm making another tangent arc and getting this particular portion completed. And here you can extract this particular sketch on the other plane, so you can choose the target as the copied mesh, and you can continue on with your diagram. So here I'm like hiding my sketch again, and I'm doing the tracing process one more time. So quite easily I am able to extract this particular sketch, and I'm making this tangent arc, and I can actually click through and make another tangent arc again. So here we can proceed on and on. So I'll make the remaining arcs. So I'm gonna select this particular mesh as my target, and I am going to fit my arcs and proceed. So here I'm selecting the last curve, the last but one curve, and I'm going to fit an arc here since it's shaped like an arc. And I'm going to right click again and select this copied mesh tool, and sketch out my final arc. So here, as you can see, we have extracted all these different cross sections and we have made out these profiles. So once we have made out these profiles, we can now use these curves to begin extracting a lofted surface. So here we have extracted the lofted surfaces this way, and if needed you can choose another additional surface and draw a plane going through in an angle. So I can go here to the draw line method and I can click and choose a direction in which I want to extract the particular plane. So here I can draw my line and select a plane, and we can make a mesh sketch there as well. So you can do a mesh sketch there, and following that you can make a sketch on it. This seems to be like a very straight arc. That's why I'm using the 3 points arc tool. Now once these profiles on the surface of this mesh are extracted this way using our mesh sketch tools and the planes, we can extract a lofted surface by going into the model tab. So here in the model tab you have a method called create a lofted surface. So you can click on loft here and you can select your profiles. So I'm going to select these profiles one by one. So you can even hide your mesh and select profile 1, profile 2, profile 3. And when you're doing that, if it flips the surface, so if I select a point here, it's gonna flip the surface to this side. So you can also click on the ball to change the direction of it. So in other words, if I select if I select a point here, it's going to select it correctly in the same orientation. Then if I select another point accidentally on this side, please do not worry, just click on that deep looking ball again. And I'm selecting another particular profile. So here we have made a lofted surface going across these profiles. We extracted the profiles by using the scan and using their cross sections. We made the sketches by using the best fit approach, and here we have exported all these. We have made our lofted surface by selecting all these 7 profiles. Like in CAD you have the regular start and end constraint options, and if you are interested you can also add a guide curve, which we'll be looking into later. And you can also choose an option to merge tangent faces. So if the curves are completely tangential, you can choose this merge tangent faces so that you don't get any discontinuities on the output surface. And the result operator is insert, to which we can say OK. So here now in our model tree we have a new option called surface bodies, and it says loft 1. So you can also check your accuracy analyzer here, and you can see that it's pretty green and the surface is also looking very nice and continuous. So here we have the mesh, and here we have extracted this particular surface. This is how we can extract lofted surfaces in Geomagic Design X Go. In Geomagic Design X Go, we do not allow the option to extend a surface and to trim a surface. So for a particular case like this, you can always perform the live transfer option. So you can go to your home tab and say extract this to SolidWorks. So you can say ensure a transfer or a live transfer, and this would load up SolidWorks in the background, and it will provide you with the progress of your model. I am using SolidWorks, but you can feel free to use the CAD program that you choose from SolidWorks, NX, Inventor, Creo, etc. We support all these particular CAD and we support all these CAD software for live transfer functions. So here, as you can see, it's made that shroud. It's making those sketches of those loft profiles, and has also made this lofted surface. And at this stage, if needed, you can use your surface modeling tools. So you can come over here. I'm going to hide this solid. You can select this particular surface and extend this particular surface. So these are all CAD related features. You can extend it by 20 mm or 25 mm or whatsoever distance as needed. So here you can use either the same surface approach or the linear approach. And let's say we choose a number like 30 or 40, and we can say OK. And if we don't need all the faces, we can just choose to extend the faces that we need. So I'll hide my sketches and extend only the faces where we need to. So we needed to extend this particular face, but we can also choose to extend these two faces if needed. So I'll remove these for now and extend this particular face. Now you can come back into Design X and you can choose to proceed here as well. So you can make your own planes and cut out your surfaces. So we extracted this particular section of the blade. Now you can go ahead and extract a plane. So you can choose the pick multiple points method. Then you can choose a point here. You can choose another point there. And let us say you choose a point, some points here. You can always hold Shift on your keyboard and you can select out these particular areas. I'm gonna select a plane like that. Now once you select a plane like this, you can extract the cross section of this particular plane by making a mesh sketch, and you can drag this silhouette arrow that you're seeing to extract this particular cross-sectional profile. So you can extract that particular profile like that, and here you can see that you have a line, so you can best fit a line, and you have a line here too, so you can select that line as well. And I can trim between these two lines, so I can trim them. And if needed, you can extend by resizing them. So I'm resizing these two areas to get that particular cross section. And I can now extrude this as a surface. So I can go here into the model tab and say extrude. So I can select on this sketch here and extrude it both ways. So you can use the method midplane here. So this method is slightly different from the previous method that we used for extrude, because this is going to create an extruded surface. So here you have your lofted surface, here you have your extruded surface, and we have to do the same operation for the bottom side. So you can show your mesh and you can hide your surfaces for now, and we can make another plane. So you can choose the method on pick multiple points, and you can choose your point 1, you can choose a point 2, point 3, you can choose another, like let us say point 4, point 5, point 6, like that. So this is gonna provide you with this particular plane. So you can say OK to that plane, and then you can right click on this plane and do a mesh sketch. So here as well, since the offset arrow is not capturing the entire information very well, you can use the silhouette arrow. So this is like shining a torchlight on one end and capturing the information that passes on the other side. So here I'm gonna best fit a line, and I'm gonna best fit an arc, so I can choose the segments that I need over here, and I can trim those two together. And if needed, you can also add a fillet to smooth the transition out. And after this, I can show my surfaces, and I can extend these lines beyond the expanse of this particular other surface. So once we have completed with this, you can extrude this particular sketch as well, and you can use the mid-plane method in both of these cases. So here we have extruded another particular surface. We made two sketches of that outer shape and we extruded that. So we have already transferred it up to the loft. Now you can go here to plane, and you can say go to the home tab and transfer to your CAD program. So here I'm using SolidWorks, and you can say resume from plane 9. So you can say resume from plane 9, and the software is going to make those particular sketches, planes, and extrudes for you. So here you have this particular process completed like that. And you can choose to extend your surfaces again. So you can click on the extend command in SolidWorks, and you can finish off your model at this particular stage. So you can choose the edge that you need to extend. We need those two edges expanded, and we can also choose this edge expanded, and we can also choose this edge and this edge. Let's expand it by something like 20 millimeters and say OK. Awesome. Now you can also show your solid and see how it's performing. Okay, so here we have the solid. So I'm going to hide my solid again. Now you can perform operations like trim surface within this SolidWorks interface. Since trimming is not permitted in Design X Go, you can export the features you need to trim, and you can come over to SolidWorks, and you can just keep the items that you need in order to get the shape of this particular blade. So here we have extracted the shape of this particular blade, so I can hide the extrudes that I don't want to see now, and we have that particular structure extruded very nicely. Following this, you can certainly choose to show your solid, and you can finish the modeling here. In other words, you can say use a surface offset, and you can select the faces you need to extract for the offset, which would be these two faces, and you can give it a small gap like a 0.125 mm or a 0.25 mm, and you can extrude it correctly, following which you can use the offsetted surface to trim the blade. So I'm gonna say trim this blade and use this as your tool, and you keep only this section that you need. So here you only obtain one section which is of interest. Following this, you can apply a thickening to this particular surface. So you can say use the thicken command and apply a thickness, say like 2 millimeters. And you can merge it if needed in order to get this particular item. So here you have your blade, and here you have your thickened you have your outer housing. This can then be used with a circular pattern tool. So here you can pattern this particular body. So you can, instead of faces, you can choose bodies here. Then you can choose the direction, which would be your vector 1. So I can choose the revolve axis, and I can choose how many ever bodies that need to be revolved. So I can enter the number 15 here and say OK. And here now you have a completed model within a SolidWorks environment, and you can choose combine and options like that to add these objects together to form a single body. So you can make a drag box around these selections. Let me remove everything and select everything again and say OK. So this way we can obtain a single body, and we can see that we have recreated this particular CAD file within the SolidWorks environment. Even though it needed surfaces, we were able to extract the surfaces that we need, followed by performing just the extending and trimming process in SolidWorks. This is how we can extract lofted surfaces in Geomagic Design X Go and use it for completing the model with a very few minor steps in the CAD atmosphere. Thank you. Thank you so much.